Once we say that there is a normal condition or a basic state, there will be a perturbed state, which we call El Nino and La Nina. There are other conditions, but still, these are the dominant ones. And we said at the surface, trade winds are pushing the water away from the equator and upwelling happens, which means the subsurface ocean is also responding. The most critical thing there is a thing called the thermocline. You can look up in my oceanography course for all the basics. There is some banging going on here. Hopefully it doesn't spoil the sound too much. But essentially, as the trade winds push the water towards the west, cold waters are coming up. So the thermocline, the sharp temperature gradient below the surface, is being pulled up. And as the water does get transported westward, a lot of it goes poleward in both hemispheres, but some of it keeps going west, keeps getting heated by the atmosphere and piles up here as the West Pacific warm pool. And you can see the thermocline here is deeper because the warm pool has warm water volume that is spreading downward and also poleward. So we will see that during an El Nino, all those waters are going to be rearranged, which is what gives us El Nino. So when we say the ocean responds to the wind perturbations, let's say during an El Nino, we'll see there will be other perturbations as well. Then this thermocline moves up or down based on whether it's an El Nino or a La Nina. Obviously, if it moves down, then you get warm waters being deeper here, which means the upwelling water will not be very cold. Upwelling doesn't go away because the trade winds do not really disappear. They are just much weaker. So upwelling is weaker, which means upwelled waters are much warmer, so the colder waters are deeper below. So during the normal conditions, shallow thermocline here, deeper thermocline here, but during a during an El Nino, you have flat thermocline, as you can see here. Colder water is pushed down, warm waters have spread to the east, and warm water have spread to the east. Warm waters have spread to the east near the surface as well, and the upwelling is now limited here, so the anomalously or normal cold waters are being replaced by warmer waters, and warm waters tend to support convection in the atmosphere, so the convection spreads eastward and you get convection here. And we will define circulation in the atmosphere here. There is a circulation that is showing convection and upward movement, and 5 meters of rain that we mentioned that hits the ceiling, the tropopause, and then moves eastward in the upper atmosphere and sinks over here over the cold waters. Cold waters, high pressure; warm waters, low pressure. So you have pressure gradient, which is also producing wind because of the pressure gradient. And on the equator, Coriolis effect is very low, so you can have strong wind additions because of the pressure gradients at the surface, sea level pressure. And obviously during an El Nino, this is going to go boom towards the east and going to create anomalous rainfall here and anomalous dry weather here, as we will see later on. But here is the approximate thing. So you have now anomalous sinking of air here, anomalous rise of the air here, an entire Walker cell. This is the Walker cell, rising air here, coming back here, sinking here. There's another branch on the other side which we may talk about later, because that's how the monsoon gets affected and so on. So I have like a podcast on Walker cell and Hadley cell and the winds and so on that you can look up, but just pay attention to the normal conditions and the El Nino conditions. Why does El Nino happen every few years? We always say it happens from 2 to 7 years, and that the warm pool waters move eastward and the convection moves and the global anomalies happen. Nobody can tell you precisely why El Nino happens. We can explain why it grew after it starts, but it's very difficult to say exactly when and why it happens. But You know that trade winds have to weaken the upwelling here and permit the warm waters to survive for 9 to 12 months, which is the El Nino cycle, as we will talk about. And of course, the other story is La Nina, where the winds get stronger than normal here, more upwelling, more cold water spread further westward. You can see it's only up to here in the middle, but here it's going much further west towards the dateline. Warm waters can pile up more to the west and then create heavier rainfall here and drier than normal here, and so on and so forth. Okay, those are the El Nino, La Nina, and normal conditions. Here is the Walker cell again. You have high pressure or colder waters, so that's the Tahiti where lots of data exists, and that's what Walker used in the 1920s to define the southern oscillation. This pressure is low because warm SST is low pressure, normal conditions, high pressure, low pressure, lots of rainfall, dry desert-like conditions. Here is the Walker cell looking from the side. Rising air, lots of convection over Indonesia, maritime continent, winds coming this way and sinking here, also going that way and sinking over there. And this is dry desert here on the South American side, and the ocean upwelling and the air comes back near the surface, completes the loop, and this loop gets perturbed during the El Nino condition, which we'll come back and look at. Okay, so we'll come back and try to see what is happening now so that you can get some sense of all the claims being made on Twitter and social media platforms that are sometimes just plain wrong. Okay, hopefully these can help a little, since I've been working on El Nino for decades now. And you can read many other materials that are available online, which is what everybody is doing, but sometimes making wrong claims, unfortunately. Okay, see you the next piece, which we will where we will describe more things.